Welcome to the tutorial. In this video, I'm going to be showing you how to make procedural generation in your games in Gdevelop. Now, one thing I want to know is procedural generation is an extremely broad topic. Basically, you could make an infinite amount of videos on procedural generation because depending on what type of game you're making, the procedural generation is different. For example, in this tutorial, I'm going to be making a top-down procedural generation, kind of like for a dungeon, similar to the hit game Soul Knight. If you've ever played it, you should play if you want a better understanding of this. But for example, a game like Minecraft procedural generation works completely different. So I don't want you thinking that we're going to be going into all of them because that would never be possible. But we will be covering up the popular ones in this procedural generation. And this one, we're going to do the popular dungeon procedural generation. Now, to get into it, the first thing we're going to actually do is create a player that can move around. Because, of course, we need to be able to move around so we can see that the dungeon is actually generating itself. So first, I'm going to add a new object. I'm going to make it a sprite, and I'm going to name this player. And I'm going to create with Pisco. I'm actually not going to, because it's broken, like always. But, of course, I have sprites. What I'm going to do is make a 32 by 32 cube. I already have this in my files, so I'll get this real fast. But you can just go to Pisco and then create a 32 by 32 cube, and it'll work exactly the same as I'm doing it here. So as I get this right here, it's just a right cube. And before X out, I'm going to go into the behaviors tab, add a behavior, and the behavior that I'm going to add here is going to be the top-down movement behavior because we're making a top-down game. I'm going to keep the default controls. I'm going to set the acceleration to be extremely high value. I'm also going to set the deceleration to be also very high just so we can start instantly moving. I'm going to set the max speed to be very high, like 1000, because we want to be able to move very fast. We don't want the object to rotate, and we don't need to change anything on advanced properties here. I'm going to apply and then drag this player onto the scene and then hit preview and see if we can move. So if I preview this here, I can move around using the arrow keys and I can move extremely fast, and that's exactly what we want. And another thing that we want is we want a camera. But before we make a camera, in order for us to tell that the camera is actually working, we need an object, because if we don't have an object, we'll never know whether or not the player is moving because we're just on a blank background. So we're going to add actually the first object, which we're going to be using later, which is called the room object. And I'll explain why we're calling it room later. I'm going to have this as a sprite. And this room, I'm going to name it room. And I'm going to create with Pisco and then X out of it so I can get to this tab. Now, for this tutorial, I'm going to be using something from the asset store. This is completely free. I'm going to be using this tile dirt. And it doesn't matter what sprite you use for this. Any sprite will work. But I'm just using this tile of dirt in this case. I'm going to hit apply, drag it onto the scene, and you'll see we have this big patch. Now we have one problem here. The problem right now is that our player is under our dirt. So in order for us to make our player under the room, because we're on top of it because it's top down, we want to make a layer that's always under the base layer. So I'm going to go into our layers tab, which is over here. If you don't have your layers tab under here, you can go into the top right, and then you have this layers panel that looks like three flat like cubes or rectangles on top of each other. Click that and it'll open up the layers. Now I'm going to add a new layer. I'm going to call this layer ground. Now one thing you need to know, if you see how I have this ground over this base layer. If I have the ground over the base layer, that means the ground will appear over the base layer. But we want the ground to always be under the base layer. So I'm going to drag it under here. And now I'm going to click into the ground with a room object. And then on the layers, I'm going to click ground. And if I drag the player, now I have it right here. I have it over the ground. If I preview now, of course, nothing's going to change because we haven't made the camera. Let's make a simple camera. We're not going to make a sophisticated one. We're just going to make a very easy to make camera. So I'm going to go into the events tab and add a new event. And we want the camera to always be active, so we're not going to add a condition. And the action I'm going to add is we're going to click into other actions. And you see if we scroll down, we have layers and cameras. And we want to center the camera on an object. And the object we want to center it on, of course, is the player in this case. And the player's on the base layer, everything's fine. I'm going to hit OK. If I preview, things won't work perfectly yet. You'll see that you can't even tell that I'm moving now. You can't even tell that I'm moving. And that's because the camera, whatever objects that you want to move on the camera, you have to also set the camera to be centered on those objects as well. So I'm not only going to center on the player, I'm going to add another action. And we're going to also center the camera on the ground, which is on the ground layer. We'll not center we're still on center on the player, but just make the layer to be equal to the ground. We don't want to center on the ground. So now if I move around, you can see that, okay, this actually works like a camera. The ground isn't moving, but I am. So that's how everything's supposed to work. So now that we have a simple camera, let's first get into the procedural generation for a dungeon. Now, when it comes to a dungeon-like game, the concept here is that, I'm going to preview. The concept here is that randomly, there's going to be a path or a hallway that's created. It's either going to be north, east, west, or south. And it's going to create a path, and it's going to have another room connected to that. And basically, the next room is also going to have a random chance of having a path to the north, east, west, or south. And we're going to keep doing that for a certain amount of times until we have a random dungeon generated. Now, in this tutorial, we're going to be using the simple way. Basically, each room can only have one path that goes to it. But in the future tutorials, we're going to have rooms that can have several paths, and we're going to also have several room types. But in this case, we're only going to have one room type, which is this dirt, and we're going to have only one hallway. But this is the foundation of the procedural generation. Now, when it gets to the coding of it, or the visual scripting, it's not truly coding in this sense. We have to create an algorithm, because that's all that procedural generation games do. The hardest part of making a procedural generation game is making the algorithm. So now we have to actually set a system that effectively works. Now, this is going to be, I'm going to code some things and then start explaining. But one thing we have to know is that we have to repeat. We're going to be repeating a certain amount of code. Basically, every few seconds, or every 1 second in our case, we're going to be checking on these room objects. Does it have a room or not? Basically, does it have another room that's attached to it? And if it doesn't, then it's going to create a room based on some code, or based on some visual code in this case. So basically, the first thing we need to do is make an object variable on this room specifically, and we need to check whether or not it has a room. So by default, I'm going to add a variable, and it's going to be a Boolean variable because it only has a value of true or false. By default, has rooms is going to be equal to false. So right off the bat, this room, it'll automatically know, yeah, we need to add something to that room. Another thing I'm going to do is go into our project manager here, and I'm going to go into where it says extensions, and then add extension, and this is going to be called repeat every X seconds. And that's because every X seconds we want to check whether or not all the rooms have another room attached to them. Now this, what we're about to use, and let me start with the first piece of code. I'm going to right click, add an event group because we want to keep our code organized. I'm going to call this camera. I'm going to drag this the event under here, and I'm going to close that out. And I'm also going to add a new condition, add a new event group, and this is going to be called the algorithm. Everything under here will be based on the algorithm that we're going to be using to create our automatic dungeons. So I'm going to drag this under the algorithm. And the first thing we have to do is repeat every X seconds. We want to do a room check. That's the first thing that has to happen. So I'm going to add a condition, and things may not make a lot of sense now, but they'll make sense as we start getting into the meat of everything. So I'm going to go into other conditions, repeat every X seconds, and we want to repeat with a scene timer. Now I'm going to call this scene timer check speed. I'm going to call this check speed because this is basically controlling how fast the game is checking whether or not all the rooms have a room attached to them or not. And the speed that I'm going to be doing it at is, well, I'm just going to call it room check because that's what it does. It's going to be called room check. And I'm going to just check this. We want to create it very fast. So I'm going to put 0.5 seconds. We want to create them very fast. So now that we have that, we have to have this, you have to individually check for each instance of the room. So what I mean by this is it can't check all the rooms at the same time and then apply a code specifically, because the game doesn't know, if you're not using specific instances, the game doesn't know what object it needs to apply the event to. It doesn't know what object. So therefore, we have to use what's called the repeat. I'm going to go into this plus symbol right here. And you'll see we have these extra functions. And we have one of the most important ones, which is for each object. And like I said, this basically makes individuality. I said that completely wrong. Individuality. I was probably still wrong, but either way, basically it will check individually for each instance of our selected object. And in this case, for each room. So I'm going to drag this under the repeat for every 0.5 seconds. And the reason why I'm putting it under here is because it's a sub event. So basically this event will not be run. The game will not run this event unless this is being run, this timer. So the first thing we want to do here is check whether or not the instance or the object variable has rooms is equal to false. So I'm going to actually add another sub condition because as a general practice, whenever you have a repeat for each object event, you don't want to put anything directly under here because it's kind of tedious if you want to change it and get it from under there. So you add another sub condition under that. And what we want to check is we want to go into click into our room, type in variable, and we want to check if each has rooms variable is going to be equal to false. So we're checking if it's equal to false. So if it is equal to false, we want to do a certain thing because it's now equal to false. Now, for the sake of this tutorial, we're not going to actually be using it really here in our case, but in order to make this flexible, we're going to add another variable, and it's going to be called max rooms. Basically, the code that we're running, or the event that we're running, as is adding singular pathways. Basically, this room will only have one path, other rooms will only have one path. We need to set a variable that sets the max rooms for each level. In our case, this scene, it sets the maximum amount of rooms that can be attached to something. In our case, this is going to be 1, but I'm going to go into our scene, edit the scene variables, add a variable, and this is going to be called max rooms. It's going to be called max rooms. This is going to be a number variable, and by default, I'm going to have it as equal to 1 by default. Now, the next thing that we want to do here is check. We want to set another sub condition, so I'm going to put Shift D, or you could put right click, and then you could put add, and then add a new sub event. So now we want to run we want to do a certain thing to see if our max rooms is equal to 1. Basically, everything under this condition right here will be based on whether or not our max rooms is equal to 1. So I'm going to add a condition, and like I said, things may not make a lot of sense now, but they'll make sense as we go on. Add a condition. I'm going to go into variables, scene variables, the number variable, and then max rooms. If max rooms is equal to 1, now we have max rooms equal to 1. If max rooms are equal to 1, now what are we going to do? So now we're at the part where we have to actually start making the actual generation of the dungeon. We have to actually start making the generation. And since we're doing procedural generation is random. It's completely random. So therefore, we're going to have to use random numbers. Now, what we're going to do here is basically what's going to happen is the game is going to check. Each of these rooms is going to create a random number. It's going to create a random number and assign it to a variable. Based on that random number, for example, let's say if the number is 1, if the number is 1, it will create a room to its right. If the number is 2, it will create a room upwards, and so on and so forth. That's how we're going to structure it here. So it's going to create a random number. But of course, we have to store that random number in a variable. And since this is going to be unique to each of these rooms, it needs to be an object variable. So I'm going to double click into the room, add a variable, and I'm going to add a variable, and this is going to be called hall direction. And the reason why it's called hall direction is because we're using hallways. We're going to be using a hallway, and that hallway connects to a room. And hall direction by default is going to be a number, and it's going to be equal to 0. So that's how hall direction was going to be. So I'm going to hit apply, and now I'm going to set hall direction to be equal to a random, well, not a random number, a number that's completely out of our range. And what I mean by that is, let's say if we set hall direction equal to 1 for one room, we need to set, actually I don't need to do that here. I'm doing too much, so I'm not overcomplicating my code. We're going to set hall direction to a random number. That's what we're going to do first. So now that max rooms is equal to 1, and we want to check if has rooms is false. We want to check if that's false. And the reason why we're repeating this is just sometimes safe to be repetitive. I found that sometimes when I'm not repetitive in Gdevelop, probably because of me just misunderstanding code, but sometimes things just won't work as well. So it's better to be safe than sorry and just always check for each one of these conditions whether or not has rooms is equal to false. Just we're gonna keep checking that. This may be repetitive, but it definitely gets the job done. So we're also gonna copy this here and set has rooms equal to false. Now we're gonna set the variable hall direction to be equal to a random number. So how do we do that? I'm going to click into our room and we want to access the variable. So I'm going to type in variable and it's going to be a number variable and it's going to be hall direction. And we want to set this equal to a value. Now we want to have a random number within a certain range. So I'm going to type in random in range, random in range. And the numbers that we're going through are 1 through 4. But in our case, we're not going to do 1 through 4 right now because for testing purposes, we're only going to set it as 1 through 1. We're only going to set it as 1 through 1. So now that we have that, I'm going to add another sub event under this. I'm going to add another sub event. And once again, we're going to check if has rooms is equal to false. We want to check that once again. And another thing that we want to do is also add trigger once under here. Because if we don't add a trigger once right here, it's going to just keep changing the value. And we only want to do it once. Same thing for checking is if has rooms is equal to false. We only want this to happen once. So now we're going to click Shift D. And now we have more subconditions under here. Now this is where the real thing's happening, where we start actually generating the hallways. So if hall direction is equal to 1, we want to create a hallway first and then create a room that's attached to that hallway. So how are we going to do this? Basically, we're going to create objects that are relative to this room position. And it's going to be a flexible formula that works no matter how long this thing is and no matter how tall it is, how wide it is. We're going to create something flexible. But first, we need an object. We need an object that works as a hallway. So I'm going to create 2 objects that we're going to be using for this tutorial. I'm going to add a new object. And it's going to be a sprite. And I'm going to call this sprite hallway. And I'm going to just call it hall just so it's not long. Hall underscore H. And this stands for horizontal hallway. So I'm going to import an image. And I have this. You can find this in a link in the description of this exact thing that I'm using. But you actually don't have to use this exact sprite that I'm using. Just make sure you copy the same size as it. Because for this tutorial, we will be using a specific size. But I'll teach you how you can program a different size without the game breaking. Now we have the size of the hallway. And for this tutorial's sake, I'm setting the default size. Once again, the default size is going to be based on what you want it to be. But I'm going to put the size as equal to 640 in width. Well, that's the position. Hold on. In width, we want to be equal to 640. And in height, we want to be equal to 128. So that's the width and height. And basically, it's going to be around the middle right here. And it's going to have a connection. And then it's going to have a room right beside it. That's how it's going to look. Now, I already have a formula. And I'm going to put in the formula and then explain why the object is being created at that position. Now, let's first start with a room, the extra room that is now being created. So now, when the Boolean variable has rooms false, okay, that's good. Now we want to check if the hall direction is equal to 1. We want to check if the hall direction is equal to 1. So that's the first thing that we're checking. Add condition. Click into our room and then go into variables. And we want to check number variable hall direction if the hall direction is equal to 1. And we want to trigger this once, because especially since we're creating objects, we don't want to keep creating objects. So we want to trigger this once. Now what we want to do is create a room at a certain position. Now I'm going to put in the formula first, and then I'm going to explain it. So what the formula is room.x. It takes the x position of the room. Then it adds it with a room.width. Room.width. And then we put parentheses. And then I add it with the hall length. Now I haven't made this variable yet, but I'm going to make it soon. And the y position is going to be the same as our current room, which is room.y. Now, keep in mind the hall length, and actually I'm going to get rid of this hall length variable. We can add this later in a different part of the tutorial, but I'm going to actually just set it to be equal to 640 in our case. That's the hall length. But, of course, you'll probably want to have that as a variable in your final game. But I'm explaining the formula right now. So basically what it does is it first takes the x position of the room And the X position of the room, I'm going to set it to 0 for simplicity's sake, and also the Y position. So basically the X position, it starts off at 0 in this case, and then it adds the room.width. Room.width, that would mean it adds 512. So if I put the ground right here at 512, and then it also adds the hallway length. In our case, the hallway is going to be 640 units in our case. So then it adds 640. So 512 plus 640 is 1052. So basically it creates the room sideways using that formula. This will work no matter what position your room is in. So now that we have that, I'm going to see if this code actually works. So I'm going to hit preview. And you see that we've already created these rooms that line up. They're already lining up infinitely. But you'll see we have an issue. And the game is also lagging. Let me get out here because it's creating an infinite amount of rooms. So we can't have it generating that fast. But we're running into an issue immediately. And the issue that we're running into right now is that we are going, if I preview right now, our player is under the ground. It's under the ground. And that's because by default, whenever you make an object, when you create an object, by default, it's always on the base layer, no matter what happens. No matter what happens, it's always on the base layer. So what I'm going to do is add an object group, because we're going to be dealing with a lot of objects like this in the future that we're creating, and they need to be put on the ground layer. So I'm going to create an object group for them by going in the top right and opening up the object group panel. I'm going to add a new group, and this group is going to be named the ground layer. Basically ground underscore layer. Every single object that we want to be on the ground layer when it's created will be in this group. And the object that we want in here are room, and we want hall, the hallway. And what I'm going to do is create some code up here. I'm going to click Shift A. We have an always condition. We want this to always happen. And basically what we're going to do is we want to click into ground layer. We want to put always ground layer. I'm going to type in layer. And we want to set the layer as always equal to the ground layer. So if I preview now, when these spawn, I am always over them because they always spawn at that layer. So now that we have that, we have to start setting, we have to make the hallway as well. We have to make the hallway that connects to it as well. So let's make the hallway. Of course, we already specified that. The hallway is going to be at, I keep saying the X position, is going to be at a width of 640 and a height of 128. That's going to be the size of it. So when it spawns, when the object spawns, it spawns as default size when you drag it into Gdevelop. In our case, when we drag into Gdevelop, it's very big. So that's the size that's going to spawn at when we create it. And we don't want that to happen. So I'm also going to go into this condition that always happens. Going to add an action, click into hall, and we want to set the size to always be a certain value. In our case, we want the horizontal hallway to always have a width of 640 and always have a height of 128. So whenever it spawns, it'll immediately set it to that size. It'll immediately set it to that size. So now that we have that, we want to also create a hallway at a certain position using our formula. Now, I'm going to add an action, and I'm going to click into hall H, and I'm going to create the object. And the formula I'm going to use here is room.x. First, we get the room's x position, and then I'm going to add the room.width, which means we're adding 512. We're adding the room.width. We're adding the room's width. And now that's the hallway. That's the hallway in terms of X position. Now for the Y position, this, remember I did this pre-made. You can set these to whatever values are fitting for your sprites. But I'm going to have the room.y. The Y is, and that means the room's Y position. And I'm going to add 193. And the reason why we're adding, because in Gdevelop, when you add to the Y, objects go downwards. And by default, if we set our Y to 0, you'll see that we're on top. So that's why we're adding 193, is because it makes it around the middle. Once again, these are depending on which your sprites are, whether or not this will work. So I'm going to, first of all, I'm going to slow down the room checking so it doesn't create these as fast. And then I'm going to hit preview. So now that we have this, you'll see that we have these rooms being created. Now, one thing you may think, well, I can kind of see it clipping in. This is not an issue because, of course, there is a fix for it clipping in, even if you're watching. But in our case, and as the case for almost all procedural generation games, the dungeon will already be loaded up the dungeon will already be loaded up before you even start playing the game. So we won't have to worry about that. The dungeon will already be loaded, so we don't have to stress about that. So now that we have that dungeon created, we want to actually limit. We want to start limiting it because we have one thing created now. We have it creating rooms sideways, but now we want to actually limit how fast, well, not how fast, we want to limit how many rooms it can make. So the last part of this tutorial is we're going to set the limit because at the moment there's a bunch of rooms being created and we can't even really see it because they're mixing into each other. So what we're going to do is set the limit. Now this is only part 1. I know it's kind of short. We haven't did much. This is not really functioning, but we're going to have another part coming on Tuesday of this week. So it's going to be very fast coming out. So the first thing we need to do is very simple to set the limit. So what we're going to do is we want this to not be attached to this. Basically, after all of this program, as all of this code is done being run, we want to then set has rooms equal to true. And when has rooms is equal to true, it will no longer be able to create any rooms because this is what allows it to create rooms. So I'm going to actually click into this one because we want to be separate from under here. So I'm going to click into this event and then put Shift A, and I'm going to set trigger once. So basically after all this is done, trigger once, and I'm going to click this, go into rooms, type in variable, and change the Boolean variable has rooms equal to true. We're going to set that equal to true. And we're going to see if this works. We're going to hit preview. Then, okay, it has a room right now. So it created one right here. And let me actually get rid of this room because it makes it look weird. So I'm going to preview and it'll wait 1 second or 2 seconds. It'll create this room. Wait again. It'll create the room. So basically we made it so it doesn't keep creating them extremely fast. It cannot keep creating rooms. As you can see, we don't have that clipping issue where it was like you will see kind of a clip of a room pop up, but you didn't actually see it after that. So that solved that problem. So this is just part 1. I'm doing this in very short parts because procedural generation is quite complicated. So I encourage you to look over this code. Once again, I've already created most of the gameplay for this already, but this is the first part of one pathway. In the next part, we're going to cover the rooms creating pathways of north, west, and then south, as well as having several rooms. Like the rooms will be able to have a pathway down and up at the same time. Things like that. So that's what's going to be covered in the next tutorial. We're making a roguelike procedural generating game. So like I said, make sure to look over this code and really try to get an understanding of it because this is the foundation of everything that we're going to be making in terms of procedural generation. So you want to make sure this is down pat. If you enjoyed the video, make sure to like, subscribe, comment down below, and make sure also become a member of Q the Game Dev as well to help support the channel and bring more awesome tutorials. We're going into a new era of Q the Game Dev with mega tutorials popping up, like very long tutorials for how to make complete games. So you definitely want to be there for that. But once again, stay tuned. This Tuesday, Procedural Generation Part 2 will be coming out. This will be a rapid fire series coming out in between all other series. So it's a lot to do. So once again, if you enjoyed the video, make sure to like, comment, and subscribe. And I'll catch you in the next tutorial. See ya.